Welcome to the deep dive. If you're like many of us preparing for that crucial senior software engineer technical interview, you're probably thinking about how to not just answer questions, but really demonstrate a deep understanding of software design principles. That's exactly what we're tackling today, a core concept that can truly elevate your responses and, show interviewers your thinking at a senior level.
That's right. We're going to explore a powerful way to handle situations where you have multiple approaches to solving the same problem in your code. It's about creating flexible, maintainable systems
Right.
and showcasing that you can anticipate future needs and design accordingly, a key differentiator for senior roles.
Absolutely. And at the heart of our discussion is a design pattern focused on managing this kind of variability. It's about making your code more adaptable, less complex, and easier to extend exactly the kind of insights that can impress in a technical interview.
So let's consider a common scenario. Imagine you're building a text editor, and a fundamental task is figuring out how to wrap long lines of text, so they fit within the display area.
Okay.
Now, there isn't just one way to do this, is there? You could have a very basic method that simply breaks the line at the nearest space.
Uh-huh.
Or a much more sophisticated approach that analyzes the entire paragraph to find the most, visually appealing breaks.
Exactly. Now, if you were to embed each of those line-breaking methods directly into your text editor's core class, what would happen?
Oh, yeah.
You'd likely end up with a massive, unwieldy class filled with different and potentially conflicting logic.
Definitely. It would become incredibly difficult to maintain, and adding a new line-breaking algorithm would be a significant undertaking.
Yeah, a real pain.
Plus, you're carrying around all that code even if you only need one or two of those algorithms in practice.
Right.
This is precisely where the strategy pattern proves invaluable. The central idea is to identify those different algorithms in our text editor example, the various line-breaking algorithms, and encapsulate each one into its own separate class.
Okay, encapsulate them.
What's really powerful is that these encapsulated algorithms are then interchangeable. The part of your code that uses a line-breaking algorithm can easily switch between these different implementations without needing to know the specific details of each one. You might also hear this called the policy pattern, by the way.
Policy, okay.
So the core insight here for your interview is the strategy pattern isn't just about code organization. It's about future-proofing your designs against evolving requirements and demonstrating a proactive approach to maintainability. That's, a hallmark of senior-level thinking.
Okay, let's delve deeper into how this actually works. To really understand the strategy pattern for your interview, it's helpful to think about the key roles involved. We often talk about an abstract class or an interface called strategy. What's its essential purpose?
The strategy interface, in our line-breaking case, could be something like a compositor interface with a method like compose.
Compose, got it.
This interface defines a common contract that all the different concrete algorithms will adhere to. So whether it's a simple line breaker or a highly complex one, they all agree to implement this basic compose method.
Okay.
The crucial point is that the context, which is the part of your code that needs to perform the algorithm, only interacts with the algorithm through this well-defined strategy interface.
Oh, so it talks to the interface, not the concrete implementation.
Exactly. This promotes loose coupling, a key principle in good software design.
Right. Then we have the concrete strategies. In our text editor example, these would be specific classes like simple compositor, text compositor, and array compositor. These are the actual working implementations of the different algorithms we're talking about, right?
That's it. So the simple compositor class would contain the code for basic space-based line breaking. The text compositor might implement a more sophisticated algorithm, maybe one that considers the entire paragraph for optimal breaks.
Like for better justification.
Yeah, exactly. And the array compositor could be designed to break content into fixed-size chunks, perhaps for displaying items in a grid or something.
Makes sense.
Each of these concrete strategy classes implements the compose method defined in the compositor interface, but each does so in its own way, providing a specific algorithmic approach. This is where the real work happens.
And the final key component is the context. What role does it play in this pattern?
The context, in our text editor example, would be the composition class that manages the text being displayed.
Okay, the thing holding the text.
Right. The context is the one that uses a strategy object. It holds a reference to an instance of a concrete strategy. We can say it has a strategy.
Has a, right.
When the context needs to perform the algorithm, for instance, when the text needs to be laid out on the screen, it delegates that responsibility to the currently selected strategy object. by calling the method defined in the strategy interface, like compose. The context might also provide any necessary data, like the text itself or the available width to the strategy at this point.
So the composition class itself doesn't contain the specific line-breaking logic. Instead, it has a kind of slot where you can plug in different compositor objects.
Exactly.
And it simply tells that compositor to execute its line-breaking algorithm.
This makes the composition class much cleaner and more focused, right?
Precisely. You've got that has a relationship, composition has a compositor, and you have delegation. Composition delegates the composition task to the compositor.
Delegation, okay.
And the specific concrete compositor that the composition uses can even be chosen at runtime, providing a significant degree of flexibility.
Yeah.
So, yeah, to reiterate for your interview, this separation of concerns is a major benefit in managing complexity.
Okay, I can see how this design promotes modularity. So when you're in an interview, what are the key advantages of using the strategy pattern that you should, highlight? Right, good question. There are several significant benefits, and these are the points you'll want to clearly articulate. First, it provides a clear way to organize families of related algorithms.
Right, grouping them.
All your different approaches to solving a specific problem are neatly contained within their own strategy classes. This makes the overall structure of your code much more understandable and maintainable.
That makes perfect sense. Instead of having one large complex class trying to handle every possible algorithm, you have a set of focused, well-defined classes.
Exactly, each responsible for a specific approach. Second, it's a very effective alternative to subclassing the context.
Yeah, you mentioned that.
Imagine trying to implement different line-breaking behaviors by creating a new subclass of composition for each algorithm. You'd quickly end up with a large and unwieldy hierarchy of composition subclasses, each only slightly different.
Yeah, inheritance explosion.
Exactly. The strategy pattern avoids this explosion of subclasses by allowing you to change the algorithm simply by using a different strategy object at runtime without having to modify the context class itself. It keeps your inheritance structure cleaner and more manageable.
So you avoid this deep and potentially confusing inheritance tree just to vary the algorithm. That sounds much more elegant, especially in larger systems.
It really is. And third, this pattern can eliminate large and complex conditional statements in your code.
Oh, the if-else chains or switch statements.
Exactly. Think back to our composition repair example.
Yeah.
Without the strategy pattern, you might have a lengthy switch statement or a series of if-else blocks to determine which line-breaking algorithm to execute. With the strategy pattern, that entire conditional logic just disappears because you're simply delegating the task to the currently selected strategy object.
Right, the logic is inside the strategy object itself.
Precisely. This makes the code much easier to read, understand, and maintain. If you need to add a new strategy, you just create a new concrete strategy class. You don't have to go and modify a potentially massive conditional block, minimizing the risk of introducing bugs.
Yeah, less chance of breaking something else.
This isn't just about cleaner code. It's about reducing cognitive load for developers and minimizing risk when adding new functionality, a critical concern when leading teams or working at a senior level.
That's a huge win for maintainability. I've definitely encountered code bases where those kinds of conditional jungles become a real source of problems and, well, headaches.
For sure. Fourth benefit, it gives you the flexibility to choose the specific implementation of an algorithm at runtime based on different factors.
Like performance versus memory.
Exactly.
Yeah.
You might have different strategies that offer different trade-offs, perhaps one that's faster but uses more memory, and another that's slower but more memory efficient. The client code can then decide which strategy best suits the needs of a particular situation. So when you're explaining this in an interview, highlighting how this pattern demonstrates your understanding of long-term maintainability and reduced complexity will be key. It shows you, think about those trade-offs.
So it allows for those important design considerations where you're balancing performance and resource usage based on the specific requirements. Makes sense.
Now, it's also crucial to be aware of the potential drawbacks when considering the strategy pattern. Any good design decision involves trade-offs, right?
Right. No silver bullets.
One potential downside is that the client code that sets up the context might need to be aware of the different concrete strategy classes available
Okay.
in order to choose the most appropriate one. This implies a need for clear documentation or just a good understanding of what each strategy actually does.
That makes sense. If you have multiple line-breaking algorithms, the part of the code that creates and configures the composition object might need to know which compositor is the right one for, like this specific document or view.
Exactly. Another potential issue is the overhead of communication between the context and the strategy.
Communication overhead. How so?
Well, the interface defined by the strategy might need to be quite general to accommodate all the concrete strategies.
Right, the common denominator.
As a result, the context might end up passing data to a strategy object that the specific strategy doesn't actually need. Simpler strategies might just ignore some of the information they receive.
So the strategy interface might be a bit of a generalized contract, even if some specific strategies only utilize, say, a subset of the information passed to them.
Exactly. And finally, the strategy pattern can potentially increase the number of objects in your system.
More classes, more objects.
Yeah, you'll have separate strategy objects in addition to your context objects. However, it's worth noting that in some cases, if the strategy objects don't maintain any internal state, if they're stateless, you might be able to share them across multiple context instances.
Oh, like a singleton or something.
Kind of, yeah. That's a concept addressed by the flyweight pattern, which can optimize this in some scenarios.
Okay, flyweight. Another pattern for another day, perhaps. So there are trade-offs to consider, but the benefits in terms of flexibility, maintainability, and reduced complexity often outweigh the drawbacks, especially in more complex applications where these factors are critical.
Definitely. Let's briefly touch on some implementation considerations that might come up in an interview. You'll need to define clear and concise interfaces for both the strategy and the context. That's key.
Good interfaces are always key.
Always. Now, when it comes to how the context provides the data to the strategy, you have several options. You can pass the necessary data as arguments to the strategy's algorithm method, like the compose method.
And pass it in the call.
Right. Alternatively, the context could pass a reference to itself as an argument.
Pass this.
Yeah, allowing the strategy to query the context for any specific data it requires. Or, in some more tightly coupled scenarios, the strategy might even hold a reference back to the context.
Okay, different ways to get the data flowing.
Yeah, the most suitable approach really depends on the specific needs of your algorithms and the level of coupling you want or can tolerate between the context and the strategies.
I've also seen examples, particularly in C++ Goal, where templates can be used for selecting the strategy at compile time. How does that relate to the classic strategy pattern?
That's a good point. It's a bit of a variation, sometimes called static strategy.
Static strategy, okay.
If you know at compile time which specific strategy you want to use, and it's not going to change during the execution of your program, you can use C++ templates. You configure your context class with a particular strategy class as a template parameter.
So the compiler wires it up.
Right. This can sometimes lead to more optimized code because the strategy is resolved statically. But, and this is the key difference, it sacrifices the runtime flexibility that is a hallmark of the traditional strategy pattern, where you can swap strategies while the application is running.
Gotcha. So compile time versus runtime choice. That static approach is valuable in high-performance scenarios, maybe, where runtime overhead needs to be minimized.
Exactly. If the choice of algorithm is fixed and performance is critical, it's a valid option. It demonstrates an understanding of those performance-critical design decisions.
And what about situations where you might not always need to apply a specific strategy? Like maybe there's a sensible default.
Yeah, absolutely. In those cases, you can make the strategy object in the context optional. Maybe use a null pointer or an optional type.
Okay.
The context would then check if it has a valid strategy object associated with it before attempting to use it. If no strategy is currently set, the context can simply execute some default behavior.
So it falls back to a default if no specific strategy is plugged in.
Exactly. This can be a useful way to handle cases where the default behavior is sufficient for many situations, and clients only need to provide a custom strategy for more specialized requirements.
It's interesting to see how these implementation details can be adapted.
Yeah.
Now, this isn't just an abstract theoretical concept, is it? Where might someone encounter the strategy pattern in real-world software development?
Oh, absolutely not. Our text editor example with the simple compositor, text compositor, and array compositor is a direct and practical application.
Right, the line breaking.
But the strategy pattern appears in many other domains as well. Consider compilers.
Compilers? How?
Well, different optimization strategies. Things like register allocation algorithms or instruction scheduling policies. These can be implemented as separate strategy classes that can be plugged in based on the target architecture or the desired optimization level, like NATICO 2 or NACO 3.
Ah, okay, that makes sense.
Financial modeling systems often use different pricing algorithms for various financial instruments, options, bonds, whatever. These can be implemented as strategies.
Different ways to calculate value.
Exactly. Even within standard libraries, you might see it in how collections manage memory allocation, using different allocation strategies. Maybe one for small objects, one for large objects.
Right. Allocators.
Other examples include circuit layout and routing algorithms in EDA tools, electronic design automation, and even input validation in user interface dialogues.
Input validation.
Yeah, different validation rules like checking for a valid email format or a number within a specific range or minimum password complexity. Each rule can be a pluggable strategy.
Wow, it really has a broad applicability across different kinds of software.
Yeah,
It's clearly not limited to just text processing or complex algorithms.
not at all. And just to loop back, going back to our initial text formatting example, the compositor pattern with its composition class and the various compositor subclasses we mentioned, simple compositor, text compositor, array compositor, that is actually a specific instance of the strategy pattern applied to the particular problem of composition algorithms in document formatting. The concrete compositor classes are the concrete strategy classes in that context.
Okay, so compositor is just strategy applied to layout. Got it.
Pretty much.
So, to summarize for those prepping for their interviews, the strategy pattern gives you a powerful mechanism for encapsulating algorithms and making them interchangeable. By doing that, it leads to more flexible, maintainable, and extensible code, avoids those messy conditional logic blocks, and promotes better organization. All crucial things that demonstrate senior-level thinking in software design.
Precisely. And here's a final thought for you to consider as you prepare.
Huh?
Think about projects you've worked on. Where did you encounter different ways of solving a particular problem?
Okay.
How could the strategy pattern maybe have been applied in those situations to create a more elegant and adaptable solution? Understanding not just the what of design patterns, but the why and how of their practical application. That is what will truly set you apart in your interview.
That's a fantastic point to reflect on. Definitely worth spending some time exploring these design patterns and thinking about their real-world applications and trade-offs. Thanks for this really insightful deep dive today.
My pleasure. Good luck with the prep.